My name is Melissa Grunland. I am an associate professor in the Department of Biomedical Engineering at Texas A&M University. My area of research focuses on developing new polymer biomaterials to improve how current medical devices function or to make new medical devices, as well as polymers that can be used for regenerative therapies. One of the most interesting projects I think that we're working on right now is the development of a self-cleaning membrane for a glucose biosensor. This would be a biosensor that could be placed inside the body of a diabetic patient so that they could monitor their glucose levels, their blood sugars at all time points during the day, during the night. Right now what diabetics have to do is they take finger prick tests where they draw a blood sample and place it on a strip inside a glucose meter. This is encouraged to be done maybe 4 times a day or more. Many patients don't comply even with this because it's uncomfortable, it's inconvenient, or they just might forget. So having an implanted glucose biosensor that could continuously monitor your glucose levels would really revolutionize how diabetics monitor their blood sugar levels. What we're trying to do, specifically with the self-cleaning membrane, is to make the body accept and not reject a glucose sensor that's implanted, let's say, at the wrist, just below the skin. So the body normally has this built-in mechanism to say, okay, there's a foreign body, in this case, a sensor that you've implanted in. And the body says that shouldn't be here, and so we're gonna seal it off. We're gonna send in cells and proteins, and eventually that sensor is sealed off from the environment. Glucose is no longer getting to the sensor, and then finally the sensor won't work. So really the big hurdle is a self-cleaning membrane that we're trying to develop. So this would enable the sensor to function over a long period of time. And so this self-cleaning membrane, it's basically a hydrogel material. It's like the material that you see in your soft contact lens. It's very soft, hydrated, squishy-like material. But what we've done specifically is to use a thermo-responsive hydrogel. This is a hydrogel that when you heat it, it collapses, and when you cool it back to body temperature, it reswells. So the big idea for the self-cleaning membrane is that you would wrap it around your glucose sensor. It would be implanted just below the skin subcutaneously, and the person would wear a watch-like device over their implant. Well, this watch-like device would be the meter that's reading the glucose level signal coming from the sensor, but it would also have a heating element that would be attached to the watch. So periodically, the heating element would heat the skin, through the skin, the membrane would collapse, and that process kicks off cells and proteins. That's the cleaning process that the membrane goes through. And so when it cools back down, it reswells, and then that newly clean membrane allows the glucose to diffuse through it to the sensor, and that diabetic patient then can start to resume measuring their glucose levels.